different forms of intermediate code. There are three different forms of intermediate code. Those are abstract syntax tree, polish notation, and three address code. So the first one is abstract syntax tree. Abstract syntax tree is nothing but it is a way of representing the syntax of the programming language as a hierarchical tree like structure. This structure is used for generating symbol tables for compiler and later code generation. The tree represents all the constructs in the language and their subsequent rules. So abstract syntax tree are more compact than the parse tree and can be easily used by the compiler. So in this way the abstract syntax tree can be represented. If you take this example, you can clearly understand. So for example, consider this grammar: E tends to E plus E, E tends to E star E, E tends to E, and E tends to ID. So the string is ID plus within the braces ID plus ID star ID. So now first we need to construct the parse tree. So E tends to within the braces E, and E tends to E star E, E tends to E plus E, and E tends to ID. So this is our parse tree. So parse tree is nothing but in parse tree we are going to declare everything which we are using in the production. So in abstract syntax tree we are going to use only the operands and the operators. So here first, like our expression given string we are taken as star according to the precedence, operator precedence star, and star we have taken as plus, and star is being given to id and plus id. So our string is id plus id star id. So this is the construction of abstract syntax tree. So abstract syntax tree is nothing but it is representation of the syntax of a programming language as a hierarchical tree like structure. And the second one is polish notation. Polish notation is of three types: infix notation, prefix notation, and postfix notation. Infix is nothing but if an operator is placed in between it is called as an infix notation. Prefix is nothing but before if an operator is placed it is called as an prefix notation. And postfix notation, notation is nothing but after the it is placed it is called as an postfix notation. So here polish notation is also called as a postfix notation. It is useful form of an intermediate code if the given language is an expression. Postfix notation is a linear representation of syntax tree. So if we are representing in a form of a linear way, the syntax tree is represented, it is called as the postfix notation. And any expression can be written unambiguously without the parenthesis. So here for example we considered as x plus y. So this we need to convert into postfix notation. So x y plus, so it will be converted as x y plus. So the plus will be shifted to the end of this. So this is called as the postfix notation. So for example, consider this one example. So here we will be shifting according to the operator precedence. So the precedence will be according to the Bodmer's rule. So starting the first preference will be given to this braces, and then next star and division, and next plus and minus. So consider this example: k plus l minus m into n plus within the braces O cap P star W divided by U divided by V star T plus Q. So now here by using the temporary values we will be changing this expression into the postfix notation. So here according to the operator precedence, here the first precedence is given to this braces. So that we are going to place this in a temporary value t1. So k plus l minus m star n plus this o cap p is being assigned to a temporary value t1. So right here t1 is equal to o cap p. So that is, when doing the postfix, it will be converted as op cap. And write the remaining expression star w slash u slash v into t plus q. And next precedence will be given to slash. So k plus l minus m into n plus t1 star. So in place of w slash u, we are placing a temporary value t2 slash v into t plus q. So t2 is what in place of what we have assigned t2, w slash u. So that the postfix notation for that is w u slash. And next operator precedence is slash. So k plus l minus m star n plus t1 star. So this t2 slash v, we are assigning a temporary value of t3 star t plus q. So t3 is nothing but t2 v slash. So that we need to write here. And next operator precedence is star k plus l minus t4 plus t1 star t3 star t plus q. So here in place of this m star n, we have replaced it with t4. So t4 is nothing but mn star. And next precedence is for star, that is k plus l minus t4 plus this, in place of t1 star t3, we are replacing it with a temporary value t5 star t plus q. So t5 is what? t1 t3 star, that we need to write here. And next k plus l minus t4 plus t6 plus q. So here t6 is nothing but t5 t star. And t7, the next operator precedence we are giving for plus. So in place of this k plus l, we are assuming a temporary value as t7 minus t4 plus t6 plus q. So t7 is nothing but kl plus. And next, so t7 and t minus t4, this we are assuming as temporary value t8 plus t6 plus q. So t8 is nothing but t7 t4 minus. And t8 plus t6, this we are assuming as temporary value of t9 plus q. So t9 is nothing but t8 t6 plus. And this whole we are assigning for the temporary value of t10. So t10 is equal to t9q plus. So now we'll check whether the postfix notations are being derived or not in a reverse manner. So consider from this, t10 is what? t9q plus. So t9q plus I have taken. So what is t9? t9 is t8 t6 plus. So in place of t9, write t8 t6 plus. And what is the remaining? We have q plus. Now in place of t8, what we have there for t8? t7 t4 minus. t7 t4 minus, and the remaining t6 plus q plus. Now in place of t7, so for t7 what we have? kl plus. So t7 we are substituting kl plus and write the remaining statement t4 minus t6 plus q plus. Now kl plus, in place of t4 what we have? In place of t4 we have mn star. So mn star minus t6 plus q plus. And next, in place of t6, what we have here? t6 is equal to t5 t star. So t6, in place of t6 you need to substitute it with t5 t star. So the expression will be changed to kl plus mn star minus t5 t star plus q plus. And KL plus Mn star minus in place of T5. So in place of T5 we have T1, T3 star and the remaining expression T star plus Q plus. And next KL plus Mn star minus in place of T1. In place of T1 we have OP cap and the remaining expression T3 star T star plus Q plus. And KL plus Mn star minus OP cap in place of T3. In place of T3 we have T2 V slash and the remaining expression star T star plus Q plus. And KL plus Mn star minus OP cap in place of T2. In place of T2 we have WU slash and the remaining expression V slash star T star plus Q plus. So now check whether the operators has been placed at the end of the symbols or not. So here check here KL plus postfix notation Mn minus Mn star minus OP cap WU slash V slash star T star plus and Q plus. So in this way we need to write the postfix notations. And the next one is 3 address code. So 3 address code is nothing but it is an intermediate code. It is used by optimizing compilers. In 3 address code, the given expression is broken down into several separate instructions. These instructions can easily translate into assembly level language. Each 3 address code instruction has at most 3 operands. It is a combination of assignment and a binary operator. So in 3 address code, we can take only 3 operands. We cannot take more than 3 operands. So in that, it is we can have assignment and a binary operator. So in 3 address code, there is at most 1 operator on right side of an instruction. So to the right side, there should be at least one operator. So for example, consider here, consider this example, A plus A star of B minus C plus D star of B minus C. So now this expression should be converted into 3 address code. So 3 address code, in 3 address code we have at most 3 operands. So here we can consider assignment operator and a binary operator, and to the right hand side we need to have one operator. Okay, so now consider here first B minus C. Within the braces we have B minus C. So B minus C is assigned to a temporary value of T1. So T1 is equal to B minus C. Okay, so this is been completed. B minus C is completed. And next, so A star in place of B minus C we have substituted with T1. So this A star T1 can be assigned to a temporary value of T2. So T2 is equal to A star T1. And next, so this whole value is assigned to T2. Now A plus T2 can be assigned to a temporary value of T3. So T3 is equal to A plus T2. And next, so T4 will be assigned to D star. B minus C we have already considered as T1. So T4 is equal to D star T1. And now, so this is considered as T4 and this is considered as T3. A plus T2, this is considered as T3. So now whole expression we are assigning to a temporary value T5. So T5 is equal to T3 plus T4. In this way we are going to write the 3 address code. 3 address code, the name itself is telling that it should have only 3 operands. It should have only 3 operands, not more than 3 operands. In that we can consider one operator on the right side of an instruction. So in three address code, we have quadruples, triples and indirect triples. So let's see what is quadruples. Quadruples, it has four fields: operator, argument 1, argument 2 and result. So consider this expression: A is equal to minus B star C plus D. So here this minus B is termed as an unary minus. So this B is assigned to a temporary value of T1. T1 is equal to minus B. And next we have C plus D. So C plus D is assigned to a temporary value of T2. T2 is equal to C plus D. So this whole we are assigning as T1. Minus B is assigned to T1. C plus D is assigned to T2. So T1 star T2. This has been assigned to a temporary value of T3. T3 is equal to T1 star T2. So now this all belongs to T3. So now A is equal to T3. A is equal to T3. So the quadruples, I said, we have four fields: argument 1, argument 2, operator and result. So now let's construct this quadruples table for this. So argument 1, based on this given expression, in this given expression, the argument is 1 is minus B. So the argument 1 is minus B. So here the operator is unary minus, and this result is stored in T1. So from this three address code only we can easily construct this quadruples table. And next one, C, argument 1 is C, argument 2 is D, operator is plus, and the result is stored in T2. So argument 1 is C, argument 2 D, operator is plus, and the result is stored in T2. And next is T3 is equal to T1 star T2. So here argument 1 is T1, argument 2 is T2, and the operator is star, and the result is stored in T3. So argument 1 T1, argument 2 T2, and the operator is star, and the result is stored in T3. And here A is equal to T3. So here argument 1 is T3 and the operator is equal to, and the result is stored in A. So argument 1 is T3, operator is equal to, and the result is stored in A. So in this way we are going to construct a table for the quadruples. And next one is triples. So in triples, it consists of three fields: operator, argument 1 and argument 2. Based on the above example only we have constructed this. So argument 1 here is B and the operator is unary minus. And the next, argument 2 is C and argument 2 is D, operator is plus. And next, here argument 1, here we have considered, in quadruples we have considered the temporary values, but here in triples we will be just considering the serial numbers. So here the C plus D is considered as serial number 1 and minus B is considered as serial number 0. And now, so argument 1 is 0, argument 2 is 1 and the operator is star. And now argument 1 here is 2. So that, and the operator here is equal to. So here in triples it consists of three fields: argument 1, argument 2 and operator, as well as we consider the serial number also. So triples are alternative ways for representing syntax tree or directed acyclic graph for program defined names. Argument 1 and argument 2 may be pointers to symbol table for program variables or literal table for constant, or pointers into triple structure for intermediate results. And the next one is indirect triples. Indirect triples are used to achieve indirection in listing of pointers. That is, it uses pointers to triples than listing of triples themselves. So in triples we have seen it consists of argument 1, argument 2 and operator. So here in indirect triples what we are doing is we are using a pointers, means indirectly we are storing this value in some pointers. So for example, the 0 is stored in the value 10, 1 is stored 11, 2 is stored in 12, 3 in 13. So the reference, the pointers we are using here, indirectly we are using pointers to triples. So first this table we need to draw, like whatever the serial numbers we have taken, for that we are assigning some different values for that. So symbol tables will do this. And so next, now we need to construct the table for this indirect triples. So the expression taken here is A is equal to minus B star D plus C plus of minus B star D. So here it consists of operator, argument 1, argument 2 and the statement number or serial number. So here first consider the argument 1. So the argument 1 is B and the operator is minus. So that is nothing but the serial number 0 we supposed to start. So 0 is alternatively it is given indirectly the value as 10. So here that is the reason we have used the value 10. And so this minus B is completed, and next star D. So star D, and here the 0 value is nothing but the argument 2 we have taken here. And next so in place of this 1 we are writing 11, 2, 12, 3, 13, so on 6, 16. Clear? And the next one is, after the completion of this we need to go for plus C and the argument 1, like in argument 1 we have that is a D star. So here the argument 1 is C and argument 2 is 1. So in 1 what we have D star. So that's the reason we have taken as argument 1 as C, argument 2 as 1. So in the same way this we will consider, and in this format we are going to consider this indirect triples. So from this, like first if you construct the 3 address code, it will be clear for you. So the argument 1, argument 2 and the operator. So in place if you feel like this is confusion for you, so in place of argument 2 you can write these values and you can construct the table like previously how we have constructed for triples and quadruples, the argument 1 and argument 2. So you can construct that and you can take this.